Welcome to the deep dive. Today we're going to attempt something pretty ambitious. We're looking at a conceptual hypothesis that asks you to just fundamentally redefine the canvas of reality itself. We're basically moving away from this classical idea of a smooth, empty space to, well, something much, much stranger.
Yeah, in this deep dive, it's all built from a set of conceptual documents. They outline a really new paradigm, something called the Interleaving Networks Theory. And it's less about adding new things to the universe. It's more about, rebuilding the universe from the ground up.
Okay, let's try and unpack that. So the one-sentence thesis is this. Reality is built from discrete 3D networks, little nodes and connections, and multiple networks like this can coexist in the same volume. And the consequence of that is massive. Quantum phenomena, extra dimensions, huge cosmological effects. They're all just the relations between these networks.
Exactly. The foundational shift here is what's so fascinating. We have to stop thinking of space as this continuous passive background, like a static stage. This model suggests space itself is a structural, discrete, almost programmable object.
Mm.
And it means concepts that we treat as abstract, like phase, or even the number of dimensions. There might just be a projection.
A projection of what?
Of a much richer, multi-layered structure that we can't see, projected onto our single layer of observation.
So we have to start right at the bottom then. We're literally tossing out the idea of smooth, continuous space. The first piece of the architecture is that space is discrete. It's a network. It's not a void. How do we even start to visualize that?
The best analogy is a super high-resolution screen. To your eye, the image looks totally continuous, smooth. But if you zoom way, way in, you see the grid of pixels. This model says space is just like that. At its most fundamental level, it's pixelated. It's made of these elementary units. You have nodes, which are like points that can hold a state, excited or not, a direction, a phase. And then you have connections or channels, and they define the relationships, the actual paths for anything to travel between those nodes.
I see. So continuity is just an illusion of scale. If the nodes are incredibly tiny and packed together, our big macroscopic world feels smooth. But underneath it all, everything is moving step by step. It's structural.
Precisely. And that gives you a completely new way to think about matter. Matter isn't some object you place into space. It's a configuration of the network itself.
Whoa, okay, so if matter is the network, not just sitting in it, what is a particle? Is it just a pattern?
It's a durable pattern, a stable one. Think of a ripple in a pond that's so perfectly ordered it just holds its shape and keeps going. A particle is a local thickening, or an ordering, or just a stable pattern of excitement within the nodes. And that configuration maintains itself. So if a force propagates, it's not crossing a void, it's just following the direct connections, node to node to node. It gives you a really intuitive local reason for why anything spreads.
That does make influence feel less mysterious. It's like an electric current in a wire, but the wire is literally space itself.
Okay. But this takes us right to the most revolutionary part of this whole idea, the main postulate, coexistence and interleaving.
Mm-hmm.
If space is this discrete network, how can you possibly have two of them in the exact same volume? Wouldn't their nodes just crash into each other?
That's the key. That's the trick. And it only works because the networks are discrete. It's all about a structural offset. Imagine you have two identical 3D lattices. Let's call them network A and network B. You place them in the same volume, but you shift network B just a little bit, a half step relative to A. So if network A has a node at position, say, 0, then network B is set up so its closest points are at like 0.5, 0.5, 0.5. They structurally just miss each other.
Precisely. The nodes of network A never ever overlap with the nodes of network B. They maintain their own distinct structures, but they occupy the same cubic meter of space. They're interwoven, or interleaved. It's not another universe next door. It's a second, fully functional 3D universe layered right inside ours.
That immediately changes the whole multiverse idea. It's not worlds somewhere else, it's worlds right here, interwoven with our reality. Structurally invisible, but spatially right on top of us. That shift from elsewhere to layered within is, well, it's profound.
And that structural difference is what keeps them independent. But they aren't totally isolated. They can be connected. The theory calls these connections couplings or bridges.
How can they have bridges if the nodes never touch?
Well, the documents describe them as being rare and local and selective. Maybe they're mediated by special kinds of nodes or some unique structural condition. They act as these little bridges, and they allow for a very specific exchange of information or energy between the layers.
And this is where fundamental physics comes from. So if we feel a force like electromagnetism in our network, It might not be action at a distance in our 3D world. It's just the effect of a local connection, a bridge to another network.
You've got it. The force isn't traveling across empty space in your network A. It's the local effect transmitted through that connecting structure into network B and maybe back again. The fundamental interactions we see become the product of these local layered relationships.
Okay, this is the centerpiece of the whole theory then, the relational dimension. If we have these two 3D structures interwoven, where do the higher dimensions, the fourth, fifth, whatever, suddenly come from?
This is the most elegant part of the model. The fourth dimension is not a new spatial direction. It's not a new axis you can point to. It emerges. It's a necessary consequence of trying to describe the relationship between network A and network B. It's a relational feature, not an absolute one.
Okay, walk me through that. I get that they're offset. But how does a simple offset become a whole new dimension? That's a huge leap.
Right, it is. So let's go back to those two interwoven 3D lattices, A and B. If you are an observer and you're stuck inside network A, everything you measure, distance, geometry, whatever, is defined only by the connections inside A. For you, your world is and always will be three-dimensional.
Okay, my reality is defined by my local connections. Makes sense.
Now, what if network B isn't just offset? What if it's also, say, warped relative to A? Maybe its internal geometry, the distribution of distances between its own nodes, is different from ours. It could be curved or stretched, but only in relation to network A.
Ah, okay. So from my perspective in network A, I feel like my world is flat. But if I could somehow perceive network B, it would look puckered or bent relative to my flat grid.
Exactly. So to accurately map the coordinates of your flat network A onto the coordinates of the curved network B, you can't just use three parameters. You can't just use X, Y, and Z. You need an additional parameter, an extra degree of freedom to describe that geometric difference, that curvature, that shift between the two 3D realities.
Ah, and that additional parameter, the number you need to describe the structural relationship, the difference between A and B, that's what we interpret as a higher order dimension.
Precisely. It's dimensional relativism. What our mathematics calls 4D or even higher dimensions might just be the product of that relationship between 3D layers. If the geometric difference is really complex, you need more degrees of freedom to calculate it, and that shows up in our math as more and more dimensions. It takes the abstract idea of curled up extra dimensions and makes them, well, structural, almost intuitive.
That is a genuinely new way of looking at it. It roots the abstract idea of dimensionality in a physical, structural mismatch that you can almost picture. So let's apply this. How does this multi-layered 3D space solve some of the puzzles of quantum mechanics?
Well, if you accept this multi-layered reality, something like superposition becomes incredibly clear. A superposition is just an excitation, a state that isn't confined to one pattern in one network. Instead, it's simultaneously represented across multiple interleaved layers.
So when a particle is supposedly everywhere at once, it's actually in one specific configuration in network A, another specific configuration in network B, and maybe more, all at the same time. The full reality of it is spread out across the layers.
Yes, and the act of measurement. That's just the moment your network, the observer's reality, enters a defined local coupling with only one of those possible layers. By coupling to it, the multi-layered state collapses into the single defined reality of your network.
What about the double slit experiment? The interference patterns, how does that translate?
Interference is what happens when a state that's spread across multiple networks is forced to recombine back onto your single network. The final pattern you see depends entirely on the phase relations and the structural shifts of those underlying layers.
So if the grid of network A and the grid of network B are slightly misaligned, where the states recombine, you get cancellation.
You get cancellation,
Yeah.
exactly. Where the contributions from the different layers agree, where they line up perfectly, you get reinforcement. The bright spots, where their structural shifts cause them to be out of sync, they miss, and you get cancellation. The dark spots. The interference pattern is literally a picture of the summed geometry of the multi-layered structure being projected onto our one layer.
And what about the spooky one, that instantaneous correlation of entanglement?
In this model, if you split two objects in our network, they aren't really two separate things. They are two shadows of a single, shared, multi-layered state that lives in the deeper structure. The correlation seems non-local to us because they are fundamentally connected at a level deeper than our 3D layer. They never truly separate at that foundational level.
This even gives a physical meaning to the most abstract part of quantum math, the complex numbers. You're saying the imaginary part, the phase, is actually coding for a real physical, relational shift between these layers.
In this view, yeah.
Yep.
Complex numbers stop being just a mathematical trick. They become a kind of shorthand for describing the actual geometric relationship and structural shift between our layer and the others. It tries to make the abstract parts of quantum mechanics physical, which removes a lot of the, philosophical weirdness.
Okay, the theory seems pretty robust at the microscale, but the ultimate test is always the cosmic scale. So let's look at the big mysteries of the universe, starting with dark matter.
Dark matter becomes incredibly intuitive here. Imagine a neighboring interwoven network has its own matter, its own stable, dense configurations of nodes. That matter might not couple with our network electromagnetically. The specific bridges needed for light just aren't there, so it emits no light in our layer.
But matter is a configuration of the network. Its presence has to distort the local geometry. It has mass.
Exactly. Its gravitational influence, its effect on the relational geometry between the layers still impacts our network. We detect the gravitational pull, the anomalous mass, but we never see a light source. It's the hidden component that lives in the interwoven layer next door.
Which bypasses the need for some exotic new particle. The matter isn't exotic, it's just in a different structure.
Okay, what about dark energy, the accelerating expansion of the universe? That could be the result of a kind of global relational tension between all the coexisting layers on a cosmic scale. Imagine the whole system of interwoven networks is constantly trying to find a stable equilibrium. That large-scale tension between the layers could manifest in our single layer as this mysterious force driving expansion.
And finally, black holes. They're traditionally a singularity, a point of infinite density. How does this model change that?
Black holes get reinterpreted. They're not just singularities, they're regions of extreme relational geometry. When a network gets that intensely dense, the relationships between the networks intensify dramatically. The structure becomes a funnel.
A relational funnel.
Yes, a region where the coupling gets so dense that the normal spatial paths inside our network, network A, are basically severed. An object passes into another network, into a subspace defined by that intense coupling. So when something falls into a black hole, it's literally passing out of the structure of our visible reality and into the adjacent interwoven one. And there's no path back.
So this one hypothesis, just by redefining space as structural and relational, it gives these really clear, intuitive explanations for things from the quantum to the cosmic.
Which does raise an important question. The sources define time in this framework too, not as a dimension, but as the sequence of network states, the flow of an observer moving through one structural configuration after another.
We started by tearing down smooth space, learning reality is a discrete network. Then we saw that multiple 3D networks can be interwoven with ours. And finally, that the geometric difference between those layers is what actually creates higher dimensions. We turn the abstract into the physical.
Right. And the ability of this framework to give you these intuitive pictures for the multiverse, for dark matter, for entanglement, all just by assuming a discrete, multi-layered reality. It makes it really compelling conceptual leap.
It's almost like a unification through visualization, which leaves us with a final thought. If time really is that ordered sequence of network states, does that mean our movement through 3D space is actually a change in our progression through that sequence of time networks? And could that relative slowing of network states be what explains time dilation? A kind of shift in layer synchronization, something to mull over until our next deep dive.